Hello viewers, I'm Keerti Bhave. Welcome to the session on electrochemical process. After going through this video, you will be able to write an electrochemical reaction and predict the products formed in an electrochemical process. Let us see what you require to carry out an electrochemical process. You require an electrolytic cell, a battery, electrodes, and electrolyte. What is an electrolytic cell? An electrolytic cell is a container in which you carry out an electrolytic process. It can be of any shape, any size, and any material. The design of an electrolytic cell depends upon the kind of reaction happening in the cell and the nature of the products formed during the process. It is an electrolytic process and therefore you require a source of current. A battery is a typical source of current which we use for an electrolytic process. What are electrodes? These are two suitable pieces to pass the electric current. Basically, this material should be an electrical conductor. Again, electrodes can be of any shape, any size, and can be made up of any material. It can be metallic or it can be non-metallic. It can be in any physical state, and you have solid electrodes, very typical. You have liquid electrodes and you also have gaseous electrodes. Electrolyte. It is the basic reactant of an electrochemical process or an electrolytic reaction. What is an electrolyte? An electrolyte is a compound which can conduct electricity because of the free mobile ions. So you have an electrolyte in the fused state, typically an electrovalent compound in the molten state which has these free mobile ions, or you have the compound dissolved in water where you have the ions. Let us see how an electrolytic reaction happens. This is a typical electrolytic cell. It has electrodes. One of the rods is connected to the positive terminal of the battery and therefore it is the anode. The other one is connected to the negative terminal of the battery, gets a negative charge over it, and it is the cathode. So you have one anode and one cathode in this particular cell. And the reactant is a fused electrolyte. There are many cations and many anions, but all the cations are of the same kind and all the anions are of the same kind. This is the electrolyte. When you pass current through this arrangement, what happens? The anions go to the anode. There, they lose the electrons and get discharged. The cations go to the cathode. There, they accept the electrons and get discharged. So because of the passage of current, you have products at the anode and you have products formed at the cathode. Remember, anions are negatively charged ions, while anode here is a positively charged electrode. Similarly, cations are positively charged ions, while the cathode is the negatively charged electrode. Let us see an example of electrolysis of fused NaCl using inert electrodes. Inert electrodes means electrodes which do not take part in the electrochemical process. They may be made of graphite or even platinum. Here you can see an electrolytic cell. There are two electrodes, one connected to the positive terminal of the battery, hence gets a positive charge, that is, it is the anode. The other connected to the negative terminal of the battery, therefore gets a negative charge over it, it is the cathode. The electrolyte is fused NaCl or molten NaCl, and therefore the electrolyte has many sodium ions and chloride ions in it. When you pass current through this setup, which has sodium ions and chloride ions coming from the ionization of NaCl, the chloride ions go to the anode, lose the electrons and get discharged. Because the atomic state of chlorine is not stable, two such chlorine atoms come together and form chlorine molecule. The electrons which are liberated at the anode through the external circuit reach the cathode. There, the sodium ions take up these electrons and form sodium. As a result of electrolysis of fused sodium chloride, sodium is formed at the cathode while chlorine is liberated at the anode. How do we write this process? It is called as schematic representation of electrolysis of fused NaCl using inert electrodes. One thing I should tell you at this point, while writing an electrolytic process, you must always mention the nature of the electrolyte. In this case, fused sodium chloride, and also the nature of the electrodes. In this case, it is the inert electrodes. So you have the cathode, you have the anode, you have to show the ionization of the electrolyte, then the reactions which happen at the cathode and the reactions which happen at the anode. So typically here we have shown the ionization of sodium chloride. You get sodium ions and chloride ions. The chloride ions go to the anode, lose the electrons. These electrons through the external circuit go to the cathode. The sodium ions take up these electrons and form sodium. That is, on electrolysis of fused NaCl, you have sodium and chlorine. Now, the physical and chemical properties of sodium and chlorine are entirely different from physical and chemical properties of sodium chloride. Therefore, this reaction or the process is a chemical reaction or a chemical process. But how did we carry out this change? We brought about this change by the passage of electric current, and hence this reaction is an electrochemical reaction or an electrochemical process. Let us see another example of electrolysis of fused copper chloride using inert electrodes. The electrolyte is fused copper chloride and the electrodes are inert. It may be graphite or platinum. The shape of the cell is slightly different. So you have an anode and you have a cathode. The electrolyte has copper ions and chloride ions which are coming from the ionization of copper chloride. The anions go to the anode, that is, the chloride ions go to the anode, lose their charge, form chlorine atom, and two such chlorine atoms come together to form chlorine gas. Similarly, these electrons through the external circuit reach the cathode, wherein the copper ions take up these electrons and form copper. So as a result of electrolysis of fused copper chloride, you get chlorine gas at the anode and copper at the cathode. How do we write this reaction? In a similar way. You will have the anode, the cathode, you will show the ionization of the electrolyte and the reactions which happen at the anode and the cathode. So copper chloride ionizes, giving you copper ions and chloride ions. Chloride ions go to the anode, get discharged. As a result, chlorine gas is liberated at the anode. Similarly, the copper ions take up electrons at the cathode and copper is formed at the cathode. So as a result of passage of current through fused copper chloride, you have copper at the cathode and you get chlorine at the anode. Let us summarize what we did today. During electrolysis of a molten electrolyte using inert electrodes, there is only one kind of cation and one kind of anion. Anions go to the anode, give away extra electrons and get discharged. The cations go to the cathode, accept electrons and get discharged. So as a result of passage of current, the products are formed at the anode and cathode. I hope you have understood the processes of electrolysis of fused copper chloride and fused sodium chloride. Wish you happy learning. Thank you.